Alright, hello everyone. My name is Adama Etinoyo and I'm going to be presenting the Koch Snowflake. Now, first question we have to answer is, who is this man? This drawing of a man. This is Hale von Koch, the so-called discoverer of the Koch Snowflake, or the Koch curve. And basically, he wrote an essay back in the early 1900s talking about the Koch curve and self-similarity, which is basically what fractals are about. Now, you must be wondering, what is a fractal? Well, fractal is a shape that shows infinite levels of self-similarity, or at least has the potential to in real life. As you can see from this plant at the bottom, the whole plant is a sort of triangle-ish shape. Then you can see they have offshoots from the stem, and those offshoots are triangles. And then those offshoots from those are triangles. And the same with this leaf pattern to the right. There's a vein going straight to the side, and then from those veins come out smaller veins, and then from those veins come out smaller veins. So self-similarity is basically the repetition of different shapes and patterns on different levels, and this has the potential to be infinite. Now, the Koch curve is a specific type of fractal that starts with the C shape of this little triangle with two lines to the side, and then they develop on it by shrinking the seed shape down and then adding it to every side of the fractal, which basically makes smaller versions of the fractal. So the big fractal is made of smaller versions, and those smaller versions down here are made of smaller versions. This is the self-similarity, and this has the potential to make infinite iterations of that self-similarity. Now, what is the Koch Snowflake? Actually, to the right, that's my drawing, just so I can get my props for that. But what is the Koch Snowflake? The Koch Snowflake is basically the Koch curve, but it's a variation of it. Basically, they took the normal Koch curve and then made it into a triangle where it has them on all sides. So this Koch snowflake is the same in that it can have infinitesimally small iterations, which means infinitely small. And it can show self-similarity on different levels, which it does by having the lines and the triangle, the big one. And then it has smaller versions like that. And we can have versions, even smaller versions on the sides of those, and even more so. So the Koch snowflake, as my drawing showed, had 3 iterations. The first iteration is the C shape, the triangle. The second iteration is the addition of the triangles on the sides of the triangle. And the third iteration is those triangles added from there. So the first iteration has an area of 15.75 inches squared and a perimeter of 18 inches. Well, excuse me. The second iteration, which is when it offshoots with these triangles to the side, second iteration has an area of 20.25 inches squared and a perimeter of 24 inches. Third iteration, which is these triangles added from there, can have 24.75 inches squared and as this area, and a perimeter of 36 inches, as you can see. Well, I hope you enjoyed my presentation. If you have any questions, email me at isstudentadai@gmail.com. Thank you.